Hi, Algebra students. I'm going to go over section 1.2 again. Even though we've already gone over it in class, I want to make sure that you see where it is and the information in the book. So we've gone over I've given you some cheat sheet notes. We've also gone over the student journal. But this is some presentation that's directly from your book that you can follow along. So this is a review of transformations of linear and absolute value functions only. We're going to write functions with translations and reflections, then add in stretches and shrinks, and add in combinations. So here we go. First of all, we talk about vertical translations, where they go up and down, where you just add the k at the end, or subtract if it goes down. Horizontally, if it goes sideways, you're going to have an h number or a constant that's right with the x. And the x, remember, goes horizontally, the x-axis. So if it's a x plus h, it goes to the left because that means h is negative. If it's x minus h, that means h is positive, and so it goes to the right because that's a positive x direction. Here's an example.
Let f of x equal 2x plus 1. A. Write a function g whose graph is a translation 3 units down of the graph of f. B. Write a function h whose graph is a translation 2 units to the left of the graph of f. Solution. A. A translation 3 units down is a vertical translation that adds -3 to each output value. First, add -3 to the output value, or f of x. Write g of x equals f of x plus -3. Substitute expression 2x plus 1 for f of x to get 2x plus 1 plus -3. Simplify to get 2x minus 2. So the translated function is g of x equals 2x minus 2. B. A translation 2 units to the left is a horizontal translation that subtracts a -2 from each input value. Subtract -2 from the input value by writing h of x equals f of quantity x minus -2. Add the opposite to get f of quantity x plus 2. Replace the input x with a new input x plus 2 in a function f of x to get 2 times the sum of x and 2 plus 1. Simplify to get 2x plus 5. The translated function is h of x equals 2x plus 5. Use a graphing calculator to graph the parent function f of x and its two transformations, functions g of x and h of x. You can see that the graphs of g and h show correct translations.
Now remember, we're not using graphing calculators, but we are using Desmos to check our answers, and these are also on the board on Friday. Also look in our notebook, they're there. So if you have a reflection in the x-axis, remember x is this way, so the reflection goes from up here to down here or down here to up here. So up, down. And all you're doing is putting a negative in front of your output values. If you want to do a reflection across this line, which is your y equals x, so that it goes right to left or right, then you're changing only your x value. So the negative goes inside. Remember, here's a study tip. When you reflect a function in a line, the graphs are symmetric about that line. So you should be able to see that here. Here's a second example.
Let f of x equal the absolute value of quantity x plus 3 plus 1. A. Write a function g whose graph is a reflection in the x-axis of the graph of f. B. Write a function h whose graph is a reflection in the y-axis of the graph of f. Solution. A. A reflection in the x-axis changes the sign of each output value. Multiply the output, or f of x, by -1. Write g of x equals -1 times f of x. Substitute the absolute value of quantity x plus 3 plus 1 for f of x to get -1 times the sum of absolute value of quantity x plus 3 and 1. Use the distributive property to get negative of absolute value of quantity x plus 3 minus 1. So the reflected function is g of x equals negative of the absolute value of quantity x plus 3 minus 1. B. A reflection in the y-axis changes the sign of each input value. Multiply the input by -1. Write h of x equals f of negative x. Replace x with -x in f of x to get the absolute value of quantity -x plus 3 plus 1. Inside the absolute value, factor out -1 to get the absolute value of negative of the quantity x minus 3 plus 1. Apply the product property of absolute value to rewrite as the absolute value of -1 times the absolute value of quantity x minus 3 plus 1. Simplify to get the absolute value of quantity x minus 3 plus 1. So the reflected function is h of x equals the absolute value of x minus 3 plus 1. Use a graphing calculator to graph the parent function f of x and its two transformations, functions g of x and h of x. You can see that the graphs of g and h show correct reflections.
This is where we're going to go over problems together in class, and now we'll go on to stretches and shrinks. We mostly started with the verticals. Remember, if a is multiplying your function, the slope is going to get steeper if a is more than 1. So if it's more than 100% increase, it's going to be stretched. If it's between 0 and 1, that means it's going to be shrunk. So the slope will be flatter. On the other hand, and that's vertical, it can also be stretched or shrunk this way, in which case the horizontal stretch is by a factor of 1 over a, where a is greater than 0. So as you can see, if a is greater than 1, it's still going to be steeper. If a is less than 1 but greater than 0, it will be flatter, like a shrink. So here's another example.
Let f of x equal the absolute value of quantity x minus 3 minus 5. Write a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. And b, a function h whose graph is a vertical stretch of the graph of f by a factor of 2. Solution. A horizontal shrink by a factor of 1/3 multiplies each input value by 3. First, multiply the input by 3. Write g of x equals f of 3x. Replace x with 3x in f of x to get the absolute value of quantity 3x minus 3 minus 5. So the transformed function is g of x equals the absolute value of quantity 3x minus 3 minus 5. B. A vertical stretch by a factor of 2 multiplies each output value by 2. Multiply the output, or f of x, by 2. Write h of x equals 2 times f of x. Substitute the absolute value of quantity x minus 3 minus 5 for f of x to get 2 times the difference of the absolute value of quantity x minus 3 and 5. Apply the distributive property to get 2 times the absolute value of quantity x minus 3 minus 10. So the transformed function is h of x equals 2 times the absolute value of quantity x minus 3 minus 10. To check your work, use a graphing calculator to graph the parent function f of x and its two transformations, functions g of x and h of x. You can see that the graph of g shows a horizontal shrink and the graph of h shows a vertical stretch.
Again, always check with Desmos. Now we'll show some examples in class, and then the combinations. So you can take any two and combine them together. And then we're going to do a modeling problem.
Let the graph of g be a vertical shrink by a factor of 2500, followed by translation 3 units up of the graph of f of x equals x. Write a rule for g. Solution. Step 1. First, write a function h that represents the vertical shrink of f. Multiply the output, or f of x, by 2500. Write h of x equals 2500 times f of x. Substitute x for f of x to get 2500 times x. Step 2. Then write a function g that represents the translation of h. Add 3 to the output, or h of x. Write g of x equals h of x plus 3. Substitute 2500 x for h of x to get 2500 x plus 3. So the transform function is g of x equals 2500 x plus 3. To check your work, use a graphing calculator to graph the parent function f of x and the final transformation g of x. You can see that the graph of g shows both a vertical shrink of f of x and a vertical translation of f of x.
Here's another one where it's actually a real-life problem.
You design a computer game. Your revenue for X downloads is given by f of x equals 2x. Your profit is $50 less than 90% of the revenue for X downloads. Describe how to transform the graph of f to model the profit. What is your profit for 100 downloads? Solution. Step 1. Understand the problem. You're given a function that represents your revenue and a verbal statement that represents your profit. You are asked to find the profit for 100 downloads. Step 2. Make a plan. Write a function p that represents your profit. Then use this function to find the profit for 100 downloads. Step 3. Solve the problem. First, write a verbal model. Your profits are equal to $50 less than 90% of revenue for X dollars. Rewrite using function notation and variables. P of X equals 9/10 times f of x minus 50, where P of X is the profit for X downloads, 9/10 is the decimal form of 90%, and f of X is the revenue for X downloads. Recall that multiplying the output by 9/10 represents a vertical shrink by a factor of 9/10, and subtracting 50 from the output represents a vertical translation 50 units down. Substitute 2x for f of x to get 9/10 times 2x minus 50. Simplify to get 1 8/10 x minus 50. So profit for X downloads is given by P of X equals 1 8/10 x minus 50. To find the profit for 100 downloads, evaluate the function P when X equals 100. P of 100 equals 1 8/10 times 100 minus 50, or 130. So your profit is $130 for 100 downloads. Step 4. Look back. The vertical shrink decreases the slope, and the translation shifts the graph 50 units down. Using a graphing calculator to graph f of x and p of x, you can verify that the graph of p